My dear student of the third secondary stages, welcome back again in a new episode of your favorite program مدرسة على الهواء. Now we are going to discuss about the application of Newton law. As we know that we cover together Newton laws, first and second and third law for Newton, and we told you that before we are going to discuss three applications for these laws. But before we start our presentation today, we have to welcome Mr. مدحت. ازي حضرتك يا مستر مدحت؟ مرحب بيك زي كل اسبوع، وبنستكمل رحلتنا مع الداينامكس النهارده، وعندنا النهارده واحد من اهم الدروس اللي هو الابلكيشنز اوف نيوتن لو. ان شاء الله هناخد ابلكيشن 1 وفي حلقه، وحلقه بعد كده هناخد فيها ابلكيشن نمبر 2. يعني ايه الابلكيشن بقى يا مستر مدحت؟
My dear, we used from Newton first and second and third law some of types of laws for Newton laws. Today we have to use these laws to solve some of examples about or application about the motion of body. Like as we have today, we will discuss the first application. First application talked about pulley, and we have a string, and in the two other ends of the string we have some of masses M1 and M2, and we discuss the motion of these two masses by using Newton's second law or third or first as we show in examples.
تمام.
Now we have to go to the application
first
number
application.
one.
Let's read it together.
Application 1.
Motion of system of two masses hanging vertically from the ends of a string which passes through over a pulley, smooth pulley. Again, motion of system of two masses hanging vertically from the ends of a string which passes through over a pulley.
We mean pulley by a smooth
pulley طبعا عشان الرياكشن بتاعها.
بالظبط.
تمام.
طيب نبتدي ندرس الكيس بتاعتنا. فهنا تعالوا نبص يا ولادي كده. عندنا a smooth pulley like this pulley, and we have string passes through this pulley, and at the two ends we have two masses M1 and M2. What about the forces acted on this body? What about the forces acted on these two bodies?
Directly we have four forces. The weight of each mass,
which is M1G
و M2G.
يبقى عندنا
acting downward.
First we have two forces M1G and M2G, and each of them
downward,
vertically downward.
تمام. وعندنا ال two tensions in the two parts of the string.
We have two tensions in the two parts of the string upward.
We have to note that if we look to the figure, we have M1G and M2G because we have two different weights. But when we look to the tension, we will find the same T. That means the tension in the two parts of a string are equal in magnitude.
Therefore, we have discussed previous, if a string passes through a pulley, then the tension in the two sides of the string are equal. يبقى بالتالي هنا عندنا two strings have two tensions. These two tensions are equal.
طيب دلوقتي we determined التايبس بتاعت الفورسز الاكتنج على السيستم كله.
Okay.
Before we start to solve this system, we have to determine the motion. الدايركشن هيمشي ازاي. مين هينزل ومين هيطلع. لأن الدايركشن اوف موشن هنا هو اللي هيحل المسألة.
بالظبط. يبقى بالتالي عندنا two masses M1 and M2. If we say that M1 greater than M2, therefore the body as if M1 moves down and the body on M2 moves upward.
اوكي.
يبقى إذا وإحنا دلوقتي بنعمل جراف للمسألة بنبتدي نحدد إيه هي الفورسز اللي بتأثر عندنا والدايركشنز بتاعتها اللي طبعا يهمنا والدايركشن اوف موشن. ده كان إيه؟ first. Now we have Newton's second law exactly.
تمام، اللي هو all forces in direction of motion minus all forces in opposite direction of motion equals MA.
بس يبقى إذا إحنا هنا هنتعرض لنيوتن second law ان ال sum of forces in the same direction of motion minus sum of forces in opposite direction equals MA. طب يلا كده بالتالي بقى نبتدي نكتب equation of motion to the two bodies M1 and M2. وطبعا طالما عندنا في bodies فيبقى في equation of motion to each of them. Then we have two equation of motions. واحدة خاصة ب M1 والتانية خاصة ب M2. طب نبدأ كده نكتب ال equation of motion. Equation of motion is for M1 then M1G in same direction of motion T represent a resistance equals MA. Therefore this equation is M1G
minus T
minus T
equals
equal
M1A.
M1A.
ونركز في حتة M1 و M2 عشان الديفرنس ميس.
بالظبط.
تمام. طيب نروح بقى للسكند بارت من السترينج، هيبقى الموشن upward.
Yes.
تمام، يبقى ال T هو ال the same direction of motion minus الويت اللي هو ال M2G
لأن الويت في الوقت ده هيعتبر ايه؟ resistance.
تمام.
بالظبط كده.
يبقى عندنا السكند ايكويشن T minus
هتبقى
M2G
T minus
M2G
M2G
equals M2A.
equal
M2A. يبقى
M2A.
كده احنا forming ال two equation of the poly of the system. From these two equations we can find out the magnitude of the tension and maybe acceleration, maybe the masses, whatever any of these symbols we can get from solving the two equations simultaneously.
قبل ما نبدأ في الجزء الثاني يا مستر وائل، في عندنا حته في كتاب المدرسه عامل لنا قانون للاكسلريشن M1 بلس M2 G على
انا مش لازم
M1
احفظ
ماينس
مش لازم احفظ
انا افضل
solve the equation.
لازم اكتب equation of motion. افضل
تمام
ان احنا لما نكتب equation of motion بعد كده بنعمل لهم solution simultaneous بنجيب اللي هو عايزه بعد كده. فانا افضل يعني ان احنا نعمل كده الحقيقه. طيب كده احنا عملنا الايكويشن اوف موشن for M1 and M2. نبتدي بقى ندرس some of remarks بقى.
البريشر اون ذا بولي.
لما نيجي نبص في الرسم عندنا how to find the pressure on the pulley. The pressure on the pulley. The pressure on the pulley, this is the pulley and we have two tensions at the highest point of the string. We have tension down T and T. These two parallel forces and same direction. Therefore, the pressure on the pulley P is equal to what?
2T.
2T. T plus T, it is equal to 2T. Then we have to get the pressure on the pulley, which is P equal 2T. P equal 2T. This is the pressure on the pulley.
Okay. نروح للريماركس بقى.
Yeah.
When you are going to talk about the remarks, we have to look again to the figure. The pulley and the two masses, and distribute the forces on the figure. T upwards and M1G and M2G downward. وبعدين خلاص احنا كده حددنا ال direction of system اللي هو هيبقى M1G downward وال M2G هتبقى upward. اوكي، ده معناه برضو يا مستر مدحت ان ال M1 greater than ال M2. الماس الجريتر ماس take the system in its direction. Okay. Number one. If the system begins motion
نبتدي بقى نقرا كده مع بعض.
From the same horizontal plane. Then the vertical distance between them after time t is equals to s. Where is the distance in time t. Again, the two masses like that, starting from the same horizontal plane,
Yeah.
like that. So let them move freely.
Freely,
then this mass will, the greater, will move downward, and this it will be go upward. So the distance between the two masses now is 2s. 2s, s is referred to the distance moved by each mass individually.
Yeah.
تمام.
لو احنا حبينا نرسمها, they begins motion from the same horizontal plane, and then the first body M1 moves distance S down. At the same time, the mass M2 moves same distance upwards S2, where S1 equal S2, and therefore the distance between them, which is S, equal S1 plus S2, and the other are equal, then S equal 2 S1 or 2 S2, where S1 or S2 is the distance which moved in time t. Moved in time t. Okay.
Okay, نروح ل number 2, remark number 2, and this is the most important remark.
Talked about what?
The cutting of the
Cutting
string.
of the string.
Cutting of string.
More important.
Okay,
حقيقة يعني.
let's discuss about it. If the string is cut after time t, then the mass m1 completed moving downward but with gravity and with initial speed, which is the final speed when the string cut. تاني دلوقتي انا عندي الماس نمبر 1 move downward بس moved with the acceleration اللي هي بتاعت السيستم اللي هي
If they
الايه.
have same the string doesn't cut
in
Yeah.
the normal position.
تمام.
When the string is cut
After
from anywhere,
time t.
Anywhere, okay, we have to evaluate the velocity of this body before the instant of cutting the string.
Yeah, at the moment of cutting of the
And
string.
this will be the initial speed.
Yeah.
And we will deal with the mass now, or this body, as a body fallen under the force of gravity. اللي هو الموشن رولز اللي احنا كنا بناخدها في سنة تانية.
Yeah. Therefore, in this case, the body M1 completed moving, but with gravity, and the initial velocity is the velocity at the moment when the string are cutting. What about M2?
ده الأهم بقى. The mass M2 completed its motion up with declaration of gravity with initial speed, which is the speed when the string is cutted, to reach the maximum height, then it rebounds again. يعني معنى كده ان الماس نمبر 2 هي كانت moving upward. مش معنى ان السترينج is cutted معناها ان it will falling down. لا, she will still moving upward by declaration to instinctually stop and rebound again.
Yeah.
When this body is instinctually stopped, this maximum height reached by the body.
تمام. يبقى maximum height at v equals 0, and u is the initial the final velocity
before the cutting of the string.
Cutting the string, and the declaration of the gravity بالماينس.
تمام.
يبقى برضو الريمارك دي
اهم تو ريماركس في الابلكيشن كله. طيب نروح للاكزامبلز.
بيتهيألي كده خلاص يبقى احنا كده قدرنا نتكلم عن ايه كل الريماركس about this
now
topic.
we have to show our students how to apply these rules and these remarks when we are going to solve some kind of examples. Example number 1, Mr. Medhat, two masses of 4 and 10 kilogram are connected by a string passing over a small smooth poly find the common acceleration. Common acceleration هي acceleration of the system.
Yeah.
يعني نفس الكلام.
Yeah.
And the pressure on the pulley. If 2/5 of the large mass is separated from the system, show that the pressure on the pulley is 0.84 of the previous value.
Now we have to graph firstly this example. We have pulley and two masses, one of them 10, the other 4, and the forces, its units kilogram. Therefore the forces acted on it is 10 mg multiply 9.8 for its weight 4 multiply 9.8. We have tension T and tension T upward, tension T upward, and then 10 moved down and 4 moved up. Now we have to find the common acceleration
by write the system equation of motion.
Okay, نكتب طب equation of motion. About 10 it is mg, which is 10 multiply 9.8 minus T equal 10A. This first. Second, T minus 4 multiply 9.8 equal 4A. Adding, cancel T, take 9.8 common factor, multiply 10 minus 4 is 6 equal 10 plus 4, it is 14A. Therefore A equal 9.8 multiply 6 divided 14, it is equal to 14 with 9.8, it is 0.7
times
4.2
4.2. تمام.
meter per second square.
ونخلي بالنا من اليونتس يا مستر مدحت.
بالظبط.
اه.
داينامكس كلها يونت زي ما
تمام.
اتفقنا.
Okay, now we get the acceleration of the system.
Yeah.
تمام.
The pressure on the pulley.
البريشر on the pulley احنا اتفقنا ان دي الفيرست كيس
مش كده؟
بتاعتنا يبقى البريشر equals 2T.
2T.
So we have to get the value of T.
Okay.
Then we substitute instead of A in one of these two
In one of them. Like 2.
equations.
From 2, equation number 2, T equal 4 multiply A 4.2 plus 4 multiply A 4.2 and minus in other side 4 multiply plus 4 multiply 9.8. Therefore T equal 4 common factor 4.2 plus 9.8, it is 14 divided, its unit now is Newton, sorry, but we have to write this in kilogram weight,
Divided
then
9.8.
divide by 9.8, 56 divided 9.8, it is equals what?
40 over 7.
40 over 7 kilogram weight. This, then we have to get the pressure, then P equal 2T, therefore it is equal to multiply 40 over 7, 40 over 7, it is equal to 80 over 7 kilogram weight. This is the pressure on the pulley. Third, third بيقول لي بقى if 2 over 5
of
of
the large mass
is
is separated.
عايزين ندرس الجملة دي شوية يا مستر وائل. 2 over 5 of the large mass is separated.
هو مبدئيا الجزئيه دي معناها ان انا بنتقل لمساله ثانيه خالص.
مش
يعني
كده؟
يعني
لأن
هنسى
أنا
كل الجزء
غيرت
القديم.
الكيس بتاعتي دلوقتي.
تمام. وبعدين نعمل كالكوليشن للنيو ماس. اللارج ماس was 10 كيلو جرام.
10 كيلو جرام.
So 2/5 of this mass it will be 4.
4
4. So the new masses now it will be 4
and 6
4 and 6.
because 2 over 5 separated.
تمام.
يبقى اتبقى 3 over 5.
اتفضل 3 over. تمام.
يبقى إذا أنا عندي أدي البولي، وبعدين عندنا 2 masses 6 multiply 9.8 tension T, and in other side 4 multiply 9.8 and tension T, and this is still down because it is the
6
greatest.
is greater than 4. تمام.
Now we have to write a new equation of motion. Therefore, for the body 6 multiply 9.8 minus C equals 6A. Second, T minus 4 multiply 9.8 equal 4A. Adding, then 9.8 multiply 6 minus 4, it is 2, and the T cancelled, equal 6 plus 4, 10A. Now A dash, we say that it is A dash, equal 9.8 times 2 over 10. Therefore, it is equals what? You can calculate this now.
1.96. 1.96.
1.96 meter per second square. Now we have to get the tension. Substitute in any of the two equations, say second, then T equal 4 multiply A 1.96 plus 4 multiply 9.8 in other side in positive, then 4 multiply 9.8 equal, it is equal to Newton.
24.
divide 9.8 يبقى تطلع عندنا كام يا سلوى؟
البي داش التي
داش
التي هتبقى 24 over 5
over 5
كيلو جرام ويت.
24 over 5 kilogram weight. Now the requirement shows that the pressure on the pulley is 0 point, which is T dash, 0.84 of the pressure value, previous value. Therefore, T dash over T is equal to T is 80 over 7 divided 24 over 5. Approximately it is equal 80 over 7 divided 24 over 5.
لا هتبقى 48 over 5 لان البريشر هنا 2 تي.
نعم.
احنا البريشر الثاني هيبقى 2 تي.
سوري.
احنا نجيب الريشيو بين البريشرز.
48. I'm sorry. عشان بريشر.
تمام.
يبقى عندنا 48 over 5 it is equal to 0.24 0.84. This is the final answer. Okay. خدتوا بالكم يا اولادي؟ يعني هي طبعا الجزء اللي هو اعتقد يعني ان هو حب يغير في المسألة شوية، هو لما قال لنا ايه؟ قال لنا if 2 over 5 of the large mass is separated، يعني معناها ان انت هتجيب تجيب acceleration جديدة، وهتجيب tension جديد، وهتجيب كمان pressure on the pulley جديد، وبالتالي نحسب البريشر في التو كيسز ونعمل لهم dividing، هيطلع عندنا 0.84. اوكي ماي دير، ثانك يو.
Thank you, Mr. Midhat. نروح directly to problem number 2. Again, we have two masses of 4 and 4.1 kilogram are connected by a string of length 150 centimeter, passing over a small smooth poly, and the two parts of the string are vertical. Prove that the resulting acceleration has a magnitude of 12 centimeter per second square approximately, and if the motion starts from rest when the largest mass is at the pulley, what is the speed of the small mass when it reaches the pulley?
يعني when it moves the distance which is 150 سنتيمتر. طيب يلا نرسم المسألة. عندنا 4.1، عندنا هنا 4 كيلو جرام forces. 4.1 multiply 9.8، the other 4 multiply 9.8 tension T moves down and moves up. Equation of motion for the first, it is 4.1 multiply 9.8 minus T equal 4.1A. Second, T minus 4 multiply 9.8 equal 4A. Adding two equations, therefore T cancelled and the 9.8 common factor. It is 4.1 minus 4 0.1 equal 8.1A. Therefore A equal 9.8 multiply 0.1 over 8.1. This equal to 9.8 multiply 0.1 divided 8.1. This equal to 0.12 meter per second square. The requirement centimeter per second square multiplied by 100, it is equal to 12 centimeter per second square. This is first requirement. Now, what is the speed of the small mass when it reaches the pulley? He says that the length of the string is 150 centimeter، مش كده؟
تمام.
يعني هنا
distance S
ده نزل 150 سنتيمتر
يبقى
والتاني طلع
150 سنتيمتر.
يبقى هنا each of them gained a velocity. What about this velocity? We know that the velocity
V
it
square
is V square
equals U square plus 2AS.
equal U square plus 2AS.
Why we use this rule? Because you are knowing zero will acceleration obtained from the system.
Because motion from rest.
Will S
Two
given 150.
0.12 and S is 1.5 meter because 150 centimeter, and we use the unit meter per second square. Therefore V equal 2 multiply 0.12 multiply 1.5 equal root answer equal 0.77 approximate meter per second. This is the velocity or the speed of the small mass when it reaches the pulley. When it reaches the pulley. Okay, my dear?
معلش كالكوليت الثانية يا مستر مدحت.
تاني 2 multiply 0.12
ايوه
multiply 1.5
تمام
equal root answer 0.6
0.6 مش كده؟ تمام
0.6
0.6
متر
متر
بير
سكند.
سكند. يا ده كانت مسألة. كل مسألة هنختلف شوية. يعني هنا في المسألة دي ابتدينا نلعب باليونتس عندنا شوية. اوكي.
Okay. To problem number 3. A string around a smooth pulley holds at its free end a mass of 4 kilogram and the other end two masses of 3 and 2 kilogram are attached. If the system starts moving from rests, find the acceleration and the speed acquired by the mass 4 kilogram after 3 seconds if at this moment the mass 2 kilogram is removed. Show that a time of 7/3 seconds will elapse before the mass 4 kilogram will first come to rest.
المسألة برضو يعني
مليانة. لا مليانة. مليانة فيها حاجات كتير
وعايزة شغل بقى. طيب نشوف نرسمها. في الجزء الأولاني عندنا string passes smooth pulley وعندنا 2 masses. في عندنا 4 والناحية التانية في 3 and 2. أنا ممكن دلوقتي أعتبرهم 1 body.
تمام.
اوكي ونمشيها ونجيب الاكسلريشن بتاعت السيستم كله. يبقى بالتالي ادي البولي وعندنا ادي التو سترينجز 5 and 4 weight 5 multiply 4.9 4 multiply 9.8 tension T tension T. نكتب equation of motion. فعندنا 5 multiply 9.8 minus T equal 5A. The other T minus 4 multiply 9.8 equal 4A. Adding, then T cancel, take 9.8 common factor, by 5 minus 4 it is 1 equal 9A. Therefore A equal 9.8 over 9, it is equal
49 over 45
over 45
meter per second
meter
square.
per second square. بعد كده بيقول ايه تاني؟ if the system starts moving from rest find its acceleration and the speed acquired by the mass 4 kilogram after 3 seconds. After 3 seconds. The set of 4 masses moves 3 seconds. They gained a velocity. Now we have to find this velocity. We have V equal U plus AT. V equal U from rest, A 3 multiply A 49 over 45. This equal to 49 over 15 meter per second. This is the velocity now at the moment that the body 2 reaches the ground.
تمام.
طيب بعد كده بيقول if at this moment the mass 2 kilogram removed يعني معناها cancelled، يعني
كأني عندي مسألة
معناها
جديدة بالتو ماسز جداد اللي
شوف
هم ال
برضه
3 وال
دخلنا
4.
بقى في حتة جديدة. عندنا مرة تانية في عندنا موشن جديدة بتو باديز، واحد منهم 3 والتاني كان 4. بس في نقطة مهمة جدا، ال 3 كانت ايه؟ still
ستيل
move
موفينج.
down.
ايوه، يعني ما نعتبرش ان السيستم غير الموشن دايركشن بتاعه.
بالظبط كده، بالظبط كده.
تمام.
هي طبعا completed this motion. فيبقى عندي هنرسمها. دي كانت البولي بتاعتنا، وعندنا ادي 2 bodies. هنا كان 3 multiply 9.8. هنا كانت ال 4 multiply 9.8. هنا tension T، هنا tension T and the equation of motion. This moves still down and this moves still up. Then 3 multiply 9.8 minus T equal 3A A dash, and T minus 4 multiply 9.8 equal 4A dash. Adding, take 9.8 common factor, 3 minus 4 negative 1 equal 7A dash. Therefore A dash equal 9 negative 9.8 over 7. This equal to negative 1.4 meter per second square. The equation, the acceleration of the system contains of the two forces 3 and 4, and 2 are removed. The requirement now, he says that
Time.
shows that a time of 7/3 seconds will elapse before the mass 4 kilogram will came to rest. طبعا هي ال 4 moves upward with retardation, then it will till have instantaneous rest. Then V is equal 0, and U is the velocity gained, and A is the new acceleration, A dash. Then we have to find the T. Then V equal U plus AT. V equal 0. U is the velocity gained 49/15 minus 1.4 T. Therefore, T equal 49/15 divided 1.4. 49 over 49/15 divided 1.4. It is equal to 7/3
seconds. مظبوط.
time 7/3 second. This is the requirement. ها يا ولاد، يا ترى خدتوا بالكم؟ شايفين شكل المسائل؟ اوكي يعني؟ ثانك يو.
ثانك يو مستر مدحت. نروح بقى لنوع جديد من المسائل في الاكزامبل اللي جاي ده. Two masses 150 and 250 grams lies on two pans, each of them of mass 50 grams, hanged by two vertical strings, passes over a smooth pulley. Find the common acceleration of the two bodies.
Yeah.
Number 2, the tension in the string. Number 3, the pressure on each pan.
هنا بقى دخلنا بقى المرة دي ابلكيشن على نيوتن سكند لو
والثيرد لو مع بعض.
والثيرد لو كمان برضه مرة تانية فعلا يعني. طب يلا نشوف. عندنا البولي، عندنا التو سترينجز، وفي عندنا two pans each of them of mass 50 جرام. حطينا فيهم 250 150. يبقى each mass of them is now
300
300
و200.
300 gram multiply 980 and 150 and plus 50, it is 200 multiply 980. And tension T, the motion down and up. Now we have to write equation of motion about the 300